Welcome to Fluttercon. My name is Bordei, and you will be seeing today some embedded experience with Flutter. So this is me. As a developer, I have more than 10 years in coding and more than 32 years in life. 3 years as a father and more than 40 tech talks spoken on tech conferences. But let's go to the interesting part. Before I begin, the talk will be more about POS hardware, but me and my friend Hannes here, we prepared a little very nice experiment, and we just launched the package for Flutter remote display. So I would like to ask the ones that are over there if they want to get closer, because I want to give you some playful device in order to test something on Flutter, and I'm really interested in your opinion. So basically, let me also film this because we'll be on camera as well. So I have here prepared a little camera. So what you'll be seeing here, 1 second, like this. Okay, it's a smartwatch, yeah? Which is, the smartwatch screen is actually rendered by the phone and streamed to the smartwatch. Actually, the smartwatch is a very low and cheap microcontroller, ESP32, for the one that knows. And me and Hannes over there, with the KDAP support, we managed to create this package of actually streaming interface, putting Flutter, as I would like to say, on an ESP microcontroller device. So I will be giving you the smartwatch and the phone to play with, and give it from hand to hand. Because I feel like this is something so revolutionary. Okay, let me, until you see that, keep it for 1 minute because we don't have all the time to see. Like, keep it and give it to the left. Basically, what we created there is a way to put a Flutter interface to microcontrollers that are not by default powerful enough to keep Flutter, yeah? So we experienced with ESP32, but we have in dev for Raspberry Pi Pico and also for Arduino and other microcontrollers. So this means like we'll be serving through multiple connectivity ways, like Bluetooth Low Energy, and TCP/IP with Wi-Fi and maybe GSM in the future. So basically, we had in mind these case studies. What if you're going on street and you want to rent a bike, and for renting that bike, you need to take your phone and actually scan a code or connect it to that bike, okay? So that bike should have, in order to provide your navigation and Spotify integration and like Android Auto experience for that particular scooter or bike, it should have some, at least dual-core processor there or something pretty powerful. But with this solution that comes for ESP32, then you can just connect to your bike with your phone, and then your phone silently, hiddenly, will stream the UI to the bike or to the scooter, or also you can watch a football match on your washing machine if you want. Yeah, so just play with it, it will go in the room, and with this being said, let's go for our topic today. Our today talks, it is also about embedded Flutter. So I'll be I don't know, I'll be, I don't have the word for it. I will travel with you for understanding what a POS system means, POS system means, about the Flutter POS and hardware. We have here some hardware. Some of them, a part of them, it is already integrated with Flutter. And we'll be discussing mainly how to integrate this hardware. Let me put this like, okay. This is the hardware, guys. I was traveling with it on the plane. Imagine how that was in the plane. That is a cash acceptor over there. that is a touchscreen display. This is an Android POS device, very nice. I will be speaking more about it. This is Raspberry Pi 4, and this is a thermal printer that is actually having a bug right now. It is not printing properly, probably because of the traveling. So let's go back. Okay, I'm here with some numbers from Romania. I am from Romania, from Bucharest, but if Romania is having these numbers, probably Europe are higher than what we show here. So in 2013 in Romania, according to these sources, we have over 230,000 POS systems used in all size stores, like from small to big stores, and over 30,000 kiosks and vending machines. By kiosk, we are mainly discussing about self-service terminals in which people are ordering food or paying their invoices or charging their, I don't know, prepaid cards. So use cases, food ordering, fiscal registering, self-service payments for invoicing and direct recharges, e-money, car washing, and ticketing. This is the market that was analyzed. So this being said, we were naturally thinking, like, if Flutter is really embedded, how can play on this kind of embedded devices? And we considered 2 years ago POC, integrating in Flutter a thermal printer, a card payment module, a coin dispenser, a cash acceptor, a barcode scanner, and a fiscal register module. And we successfully managed to achieve that. So the advantages of Flutter for multi-platform development, because this is the reason that we met here today in this particular time, it is because our app, actually the idea came from a TikTok, but TikTok it was very useful, because I was seeing this commercial of this POS Android on TikTok, and then I contacted the right people. And now, because of Flutter, I have a B2B, B2C, B2B2B, B2B2C, B2B2B business, because I can actually port my single code base with very, very particular modifications to app stores, Google Play, the Android device that you'll see over here. I will be filming it a lot when we play the demo. The same code base stands on Linux for self-service terminals, and so on. So basically, even if I'm giving you an application, that is the B2B case, in which you can directly charge your card or pay your invoices, or I can go with my POS to the store, and then the store will serve other people by just adding their data or scanning their invoices. Basically, we are covering the all business models. We found out that we have a very, very low cost maintenance, because we just need a developer on Flutter and one on backend. And now it turned out that we need also one on embedded, but it is harder to find a developer on embedded. It is called because using Flutter, like it is emergent. And this is very important. Our app, we developed the app for the Android POS, and then we just slightly modified for the other platforms. And we keep the same visibility and the same identity on all our devices, because we are pushing the design to a single code base, and that gets deployed on all other devices. And I'm still having this face when they say that we are not using Flutter. Why? Okay. So the key features and flexibility of Flutter, again, single code base, multiple targets, single payment processing backend. Yeah, we are using Supabase. We are saying that it is super duper. It is actually super duper. We are using it because of relational database and Postgre, but Firebase can go as well. Fast and stable hardware integration, reduced team with one Flutter app and just a few embedded devs. Because it's so dynamic, we are already ready to sell it white label. So because we were too lazy to do updates for the logo into assets folder, we just created an endpoint, and now we just updated it from Supabase. And yeah, we have platforms availability everywhere. We managed to put it also on PlayStation. So if you want to pay your invoice from PlayStation, you can do it with our app. Okay. This is the case study that I will be showing you the code base for. This is actually what we run in Romania. It is called International Payment System. Yeah, it is not so big, but it is a startup. But the interface for the POS, it is the one on the center. On the left side, okay, it is the self-service terminal interface. And the device that we are running, the mobile app, is this Android device fiscal register here. And also our self-service terminals looks like this, which are basically containing this cash acceptor. This is accepting cash, the thermal printer, and the Raspberry Pi with a touchscreen and a DVI display, and usually a barcode scanner. So this is the hardware that we mainly target when we want to create a device like a self-service terminal or a POS system. So we have the touchscreen. So we need Flutter to have support for the touchscreen. Thank you, Hannes, for the support for Raspberry Pi. It is perfect. He created a driver, like slightly changed, that renders directly for the FPS of Flutter on Raspberry. A barcode scanner, a receipt printer, a cash dispenser, a cash acceptor, and a card payment module. Okay, good. So those are the detailed steps to integrate hardware with Flutter for these use cases. Make sure that the platform supports the hardware connectivity requirements. Mostly it is, for example, iOS serial, it is limited, but on Android you can connect serial devices without any problem. Decide the integration methods according to which operating system you go. So we'll be speaking about method and event channel for Android and iOS, and for Linux we'll be speaking about FFI. Who's of you knows about FFI? Oh, very nice. I want to applause for that. Very nice. Okay. So you need to have Hannes' phone number for FlutterPy. And also, you can reach through a local server approach, the integration if you're not, I don't know, you have connectivity limitation. Okay, I want to show you something that, I don't know, I want to share everything that was helping me. So in order to integrate this is a cache code UAB10 for a protocol that is called ID003. Pretty custom. And I wanted to integrate it. I have the serial interface, and I was like, okay, I put the serial and I sent comments. It is not so easy. It was not so easy. And I struggled to find some good documentation, and it was very hard to find some good documentation, but I want to share with you this. If you are going to script.com and you are paying a subscription, you are able to find this kind of confidential documents. I will be not showing you the document, but believe me, it is confidential. And those documents are actually provided by JCM just if you are a partner. But people are just crazy uploading documents, and script are sharing them something legally. So if you want a good documentation, you just have to pay the €2 and get whatever you like. I found the information from this document, which is, you see the marker here, confidential. So a person was just uploading this without any, I'm not encouraging it, but come on. I just wanted to share that people, maybe you can go and flag it out, like this should be done. Okay, good. So yeah. Our configurations for today are the Android 11 Blue Cache 15, which is a POS system. It is a cash register, the only one in Romania like this. This means like they are literally biting the market in Romania with this, because they are replacing the cash registers with the Android one, and they also create this sort of marketplace for this kind of businesses, because there is no other business doing this in Romania. I don't know in Germany, but okay. So this is having a serial printer inside, not a Bluetooth, a card payment module, a barcode scanner. You can see, you can power it up from here. Let's see. Hopefully. See? A camera, you can scan also QR codes, and an LCD display if you want to see how many bananas did you want to buy. Okay, and also for the Linux side, we have the Raspberry Pi. It can run on multiple platforms as well, not just the Raspberry Pi. It can run on a Raspberry Pi 3, 4, 5 compute, and we also have successful reach Raspberry Pi 0, which is, you see, as high as my finger is. Okay, so for this, to create a POS system, you need also a serial thermal printer, which is this one. A USB barcode scanner, which I'm not having with me right now, but you can imagine it's a USB barcode scanner. The serial cache acceptor, a touchscreen display, which is this, and also if you want to pay with card, you need something legally approved in terms of encryptions and stuff. I saw some POS devices running Linux on a stand here. I forgot the name of the business, but that kind of device can be integrated also with Linux. Okay, so I will be showing you a little demo about integrating a receipt printer with Flutter on an Android device. What I did in order to be able to print something, but before of that, let me show you a little demo of the app. Who wants a little demo of the app? Thank you. It is very nice to see that people are like, okay, so I don't know what I did here. Let me restart OBS very fast. Everybody, this session, this Fluttercon session, all the speakers are complaining about the live demos. They said like, oh my God, the live demos were like the worst. Probably like it will be bad. Just think about that. I'm not the only one that is messing up. Okay, so the app is here. See, it's Flutter because of the Flutter icon. You trust me? Yeah, it's Flutter, believe me. I'll show you the code base. Okay, and what you see here is like, this is a proof of concept for a single product, but you also can see here all the categories, and I would love to see that, to show my wife that I still have the ring on my finger, because she's like, okay. You can go for the category, those are products. You can follow the product flow, which is like filling some. If you take a picture on this number, you can find me on WhatsApp and we can discuss more. Okay? And here are the products that I want to buy. Like I want a recharge of 5 euros. The 9 euros is for the demo purposes canceled. So let's take the 5 euros one. Bogdan, do you have a card? Give it to me. Okay? Because I don't have any money, man. Yeah, I'm just trying to get clients here, you see? I was just a bank card.
This is why I came with Fluttercon.
Yeah, thank you. Okay, so you just press next, and you have to choose if you want to pay cash or card. Because we have Bogdan's card, we can pay with card. And let's see. See this animation? It's actually created with just containers. There isn't a package installed for that. My developer is just amazing. So you can put this here, and you will see there's a paper coming. I'm not filming Bogdan's card. Oh, you disable it? Okay, so this is the receipt, which is like, this comes from our platform. So basically, it is very interesting how you should write a logo into the POS memory. Basically, you store it into the EEPROM memory. It's like crazy. It's not like a JPEG printed. We need to send base 64 stuff. Okay, so this is the use case that we are talking now. What do you think? Hmm? Thank you. Good. Thank you very much. Oh my God, no, I'm sweet. Good. So I will be explaining in a little what method channel means, but I will be showing you the integration between Flutter and the native Android app, because basically Flutter sends some data to Android. Android takes that data and put it into an intent for printing. Let's start with Android. So don't worry, I don't know Android, so I'm still a Flutter developer, yeah? but you can handle it. So basically what we did into the main activity, I don't know, is everybody able to see my code? Okay. So according to the Flutter documentation, which is very easy to follow in this method channel, event channel case, I created this method channel for a printer channel, which this printer channel is basically something that you create on your single, like you can put a unique name for that. I'm usually using it like this because it's, I don't know, looks more professional. Okay, after that, you can set a method called handler, and when Dart will call that method, basically you can see the name of the method. We have a switch case here. The one that printed the receipt earlier is this, non-fiscal. And basically, we are looking for some arguments, so we expect this to come from the Dart side, okay, from Flutter. Also, yeah, there are some check-ins here, and then it tries to check this method print non-fiscal receipt, which is something that came with the provider's SDK. So from this point, we were having the Android example. This is what he provided us. He said, like, you have this, make it work. So we actually made it by just sending this intent comment variant, which is, if we are going more deeply into it, is like a fiscal response on some encoding and some data that needs to be sent over serial intents and stuff. Basically, what they did on this device, they took an Android device and they also connected through serial interface the rest of the devices, including the fiscal module, and they gave an SDK like, okay, this is the code, this is the communication code, you can make it. So basically, this is the command that splits the data and prints over the printer. But my job was to send this data here, like the logo name, and also here print text with formatting, which is a method that does the same, goes for, no, this is a class, goes for sending this data to the intent. So on the Android, we have the intent level. On the Flutter side, in order to print what you saw there, we just created an instance of method channel on the channel that we just named. And also we invoke the method. Yeah, you saw here in the switch that we are doing a casting, like print non-fiscal for this case. This is the, one second. Call that method property. So we invoke the method with this name, and we send some arguments before logo text, after logo text, and logo name. Here, before we don't have nothing, we have the logo, and then we have after logo text. Okay, so this way, Flutter sends data to Android, and Android does what knows what to do. Android knows what to do there. Okay, good. And if we don't have the logo in memory and we don't have it stored locally, we just print Flutter logo on all our receipts. See? I told you it is Flutter. Good. And yeah, this is a very representative image. It is not a joke. No, it isn't. Basically, what happens is when you bridge things like this, and especially on intents, it is very hard to debug the low-level communication of the Android device with their integrations there. So we had a really hard time of integrating this, not because we did mistakes. We did mistakes, but we didn't know what mistakes we did. So it came from a lot of time. It doesn't work, why it works, why. Good. So that was the event channel, a way to integrate the thermal printer. Now I would love to show you how to integrate the native environment like macOS or Linux with something that you want to extend. So you already told me that you know FFI. FFI stands for the Foreign Function Interface, and it is a way of calling functions from other programming languages. In our case, it is Dart calling C code. Yeah, we integrate. Basically, in C, you can do whatever, like if you know C. I don't know C, but I'm learning. So Basically, you can create a custom implementation on a C library, expose it, and then you can integrate it with Flutter. So let's go for this documentation. And how much time do I have? Still 20 minutes? Oh my God, this is perfect. Let's go here for, what was the link again? This one. Okay, and I want to follow with you a small coding demo in which basically we integrate this hello world example. Yeah, what we expect is to create a C library that is printing hello world and to integrate it into the macOS. Is this something that interests you? Yes. Yeah, okay. Raise your hand, please. Who wants this demo to oh, perfect. Oh my God, I just targeted perfectly, you know? Sorry? 15 minutes. Nah. We have time. Okay, so they have in the documentation a repository, the implementation and some details. Let's go fast. By going fast, I mean let's go into the terminal, to the dark side. I think I can go to the desktop. Let's create here like a folder. Yeah, I was just about to. Let's Fluttercon demo. Okay. No. Let's create Dart create. Okay. Good. So we now go to Fluttercon demo and open it into our friend Visual Studio Code, which is zooming completely perfect. Okay, so what do we have here is basically into the example repository, which is here. We have some C code that I want to just copy. So we have the hello C file, which is basically the code that gets executed. The def file, which is used for compiling for Windows. And also the header file that tells Flutter and also tells us how to use this library. So let's create very fast those files. We can go like, what's the name of the folder? Hello library. New folder, hello library. I know that I was able to get the repo, but it's fun like this. Hello C. Very fast, very fast. Okay, hello def, we take it. Let's see. Don't get bored, please. It was amazing. Hello def, okay. And also, let's take the last one. Hello.age. From curiosity, where is my smartwatch? Thank you. Good, good, good. And my internet? No. Oh, okay. I was thinking like, I'm on roaming internet, you know? Okay, so basically this is what all that we need. I think we also need the CMake file. This one, CMake list file. And I think this is from my phone. Sorry for this. But again, roaming. Something is wrong. Good. So this goes like this. Okay, we compile it very fast, very, very fast. See, save it. Now we get back into the documentation. And what we'll be seeing into documentation after I get 1,000 backs here. So basically we go to our folder and compile this C code, cd hello library and cmake dot, sorry. I told you that I don't know C. So, and now we need to hit make and yay! So we basically have the files where here, cmake files. Where are there? Oh, those are the libraries. Okay, good. So this is everything that we need to do on the C side. Yeah, so we need to expose the code as a library. Good. Into our Dart environment, we need to go for our main file, which is here. We already have, which is here, sorry. Okay, let's install this package, wonderful package, FFI. So it's Dart pub add. Could not find, what? Sorry? Oh, thank you. Again, live demos, man. It's like crazy. Okay. Ta-da! Good. And also we need to import, I think, also path, yeah? Let's put path also the package. Good. So let's import Dart FFI into our Dart file, which is here, and we put it here, and we go then for the other dependencies. I have a meme that you need to see. Hopefully I will be having time for this. And now we start the integration of this library. So, one second. Sorry? Oh, okay. Sorry. Okay, but we can take the code from, no, let's go like this. Okay, good. Now we can put this library path variable. I will be explaining you in a little what I'm copying here, and then we can go to load the library based on the environment that we are having. So if it is Mac OS, if it is Windows, or if it is Linux, okay? So it differs. Very important, the code that you are integrating through FFI needs to be able to run on the platform that you target. So for Raspberry Pi, for example, for GPIO, I need to compile the code there, or I need to cross-compile something. Am I right, Hannes? Yeah, thank you very much. Okay, and then we can call the function hello. Good. I think Dart run. Yeah, and we have hello world. Yeah, so basically what happened here, the hello world comes from the C code that you find here. Yeah, this is the hello world that was printed. How? Basically, we loaded the library by the environment. So in this case, it is this lib hello.dilib, and then FFI is able to open that library and to look for that native function that for us is called hello world. So it is basically looking in the platform. Good. The next thing is, it's a simple question. What happened if we have, yeah, this is a good example. So there are a lot of people that are calculating pi from Dart FFI because it is faster than the original Dart math library. So just a thing to see how fast it is. But what happens if you have a C library with 2,000 functions? We know C is like more like written all in one place. So you need to integrate 1,000 functions into your Dart code, and this will be like killing a developer. You know, so what happens is what stands for helping us. It is this FFI generator, which is basically a Dart package that is able to analyze a library and to automatically expose the methods into a Dart file. Yeah. So basically, we are not having to target each function to write it by hand. It is just doing it dynamically, but keep in mind that there is no garbage collection into FFI, yeah? So you need to clean the garbage as you do in your own house. Bad joke? No, everybody's cleaning the garbage in their house. Okay, good. Let me explain you a little about event channels and method channels. Basically, what you saw there, it is a method channel or an event channel. What you saw on the printing side. Come on, come on. It is a method channel, yeah? The one that I was calling for printing the paper, yeah? Okay, so the difference between event channel and method channel, the event channel, it is used for real-time communication because on this POS device, I have two use cases. The one that I'm sending some data and I expect to happen without actually wanted to know a response. And other thing, it is the asynchronous event. For example, the barcode scanner event, yeah? So in Flutter, I know that I started the barcode listening and I want to catch the event when the barcode was scanned, yeah? For this, I am not able to use method channel. I should use event channel, which is more for real-time communication, yeah? And useful for scenarios where continuous stream of data need to be shared. And for this POS, there are two continuous stream of data for the card payment, because I need to know each status of the card module payment, yeah, in order to update the interface, and also to decide what to do with the app. And the second one, which is the barcode scanner. For the printer, we have the method channel, which is best for singular data transfers, one-way communication pattern. Good. Yeah, and also the LCD display is a method channel because we are just sending data to be shown, like this. We don't want to expect something from the display. The live demo but we are not having time, it is based on the same FFI with FFI generator that you need to research on your own. Basically what we do, let me show you just, just a little. So we have this, 1 second, too much code. Okay, so basically, zoom in, sure. We have this library here, which is basically a serial integration of the cache acceptor, yeah? So this library is able to read all the statuses of the cache acceptor, to know that we have like any denomination inside, like money, or to reset the cache acceptor. Also, we have the header file in which we are exposing the methods, some of them. I will be showing you how to run the reset method by Raspberry Pi. If my hotspot is, I don't know where my hotspot is. So yeah, we can run the demo, okay? So basically, what you will see is I will be deploying this code onto Raspberry Pi using this command. Here I created a small script file in which I'm compiling this for Mac, and also I'm analyzing the library with FFI-gen in order to generate this Dart file. This Dart file exposes the methods, including the reset one that we will be calling. And then I'm building the bundle files and deploying to Raspberry Pi, and then I'm executing the app. Let's do it very fast, like this. Hopefully it will work. So now the library got compiled, and if everything goes well, it means like something went wrong, yeah? I don't have any debugging, like it is just a code that usually works in my home. Probably it will be giving us a timeout. Yeah, so I will not be forcing it because I need to connect to Raspberry Pi. Let's go to the Q&A section.